Hello everyone. So in the last class, we had discussed about the nomenclature of aldehydes and ketones, and in today's class, we'll be talking about a few more functional groups. First functional group, which we are going to discuss, is cyanide group. We can also write it as C triple bond N, where 3 bonds are with nitrogen and 1 bond of carbon is linked to the principal carbon chain. When it is acting as the higher priority group, then the suffix will be nitrile. If it is acting as a lower priority group, then the prefix is going to be cyano. Now we have two suffixes over here. One is nitrile and another is carbonitrile. Usage of both of the functional groups is different, and hence we will look out for the conditions where we can use nitrile and where can we use the carbonitrile. We also call carbonitrile as special name. Okay, so this will be used in some special conditions only. In most of the cases, we will be using nitrile as the prefix. So let's see the general formula. General formula is RCN. When we are writing the name, we are basically writing it as alkane nitrile. Alkane is nothing else but the count of all the carbons which are present in the carbon chain will basically represent the alkane, and nitrile represent the group. So when I'm saying that I am writing alkane, I am actually counting the carbons of R plus cyanide's carbon. Okay, so R plus C of cyanide will basically give you the count of carbons for alkane, and then comes your nitrile. No space in between. Okay, so for example, the first compound I have taken is CH3C triple bond N. So total number of carbons are 2. So the chain name is ethane, and then followed by a suffix that is nitrile. We can also write it as methyl cyanide. When I'm using the term methyl cyanide, just look at it very carefully that I'm not counting both the carbons. In fact, the CN is being represented by the term cyanide, and we are taking the CH3 as methyl. So basically now when we are mentioning the carbon chain, we are not mentioning with both the carbons. Cyanide is the name for C triple bond N, where the carbon of CN is not counted, and we are just writing R group as methyl, ethyl, propyl, butyl. Basically alkyl group is being mentioned over here separately. This is the common way of naming, so we can write it as common name, which we will not use. You may find these at different places, but you will not use it, or you will never write your name like this. If the methyl cyanide comes, that means you will write CH3, and then comes cyanide group, that is CN. Okay, let's look at the next compound. Next compound we have is CH3CH2C triple bond N. Again, total number of carbons are 3, so the alkane will be propane, followed by a suffix that is nitrile. If I have to write the common name, again I will not look at the carbon of C triple bond N. C triple bond N will be represented by cyanide, and remaining chain will be the alkyl group. So basically we will be writing it as and the R will be represented by alkyl term. So here we have 2 carbons, we will be writing it as ethyl. So it will be ethyl cyanide. Again, as I mentioned, this is the common name, and we will not be writing it unless it has been asked to write a common name, or if it is given in the question. You should know how to identify the common names, but you will not be using when you are naming any cyanide compound. Okay, now look at another compound. Another compound we have is CH2, CH2, C triple bond N, and C triple bond N. So basically 2 nitrile groups we have, and then a carbon chain in between. So we will again be counting the total number of carbons for the alkyl group. So alkyl group, or you can say for the total alkane, we'll be counting the total number of carbons, including the carbons of C triple bond N. So total carbons what we have are 4. So name is going to be butane, and because the nitrile group is twice, we will be mentioning dinitrile instead of nitrile. Now here you have to understand one thing, that when I'm saying butane dinitrile, this nitrile group is a chain initiating group. Chain initiating or terminating group. So this is chain terminating and or chain initiating group. So your chain will start from here. So this is carbon 1 and this is carbon 4, and this can be the only position what your 2 nitriles can get, and that's why it is not mandatory to mention the location over here. Okay, now let's come to the next set of questions. Our next set of examples. In next example, we can see we have taken a carbon chain with 2 functional groups. One is COOH and another is cyanide. Now, because I have a higher priority group, I cannot begin my chain with CN. We know COH is a higher priority group, so we will start the numbering from here and we'll take the longest possible chain in the carbon chain. So 1, 2, 3, 4, 5, 6, and this gives my cyanide the 3rd position. Prefix for nitrile group is cyano. So it will be on the 3rd position. So it will be 3-cyanohexanoic acid. Simple. right? Next, let's understand the usage of the second suffix, that is carbonitrile, or you can say alkane carbonitrile. Alkane carbonitrile is not the suffix, by the way. Suffix is carbonitrile, but when you will name the compound name will be alkane carbonitrile. This is generally used in two cases. We have already discussed these cases before, that either the ring should be cyclic or you should have multiple CN groups present. It's the same condition uh, as we had in other cases wherever we were using the special names, multiple CN groups. So first example, if we'll see, we have cyclohexane with CN group. So we will be naming this compound as cyclohexane, and then CN will be specifically mentioned as carbonitrile. We are not counting the carbon of cyanide group or nitrile group in the counting of the principal carbon chain. So principal carbon chain is the whole cyclic ring, and your CN's carbon is not included here. That is the reason the name is not nitrile, it is carbonitrile. So we are basically representing the carbon of nitrile group by writing carbo. Look at the next compound. Again, we have cyclopentane, and here the position of CN is first and third. So we will just write 1, 3 dicarbonitrile. Okay, so we are not counting the carbons of nitrile group. Look at the next compound. We have two ways of naming this compound. One is new way of naming and another is old way of naming. First, we will understand the new way of naming. In new way of naming, what we are doing is we are going to mark the chain excluding CN. There are multiple CNs over here and we are excluding all the three CNs. So my main chain or principal chain is made up of three carbons and I have CNs attached on first, second and third, all the three carbons. So the name of the principal carbon chain is propane, and I have CN present on first, second and third carbon. I have not counted its carbon in the principal carbon chain. Hence, the name of my CN is not going to be nitrile anymore. Instead, it is going to be carbonitrile. So we will mention 1, 2, 3 tricarbonitrile. Tricarbonitrile represents that the carbon of nitrile group has not been counted in the principal carbon chain counting. If let's say I, rather than marking this way, I mark the principal carbon chain this way. Sorry. Yeah, so this is my principal carbon chain, let's say. That means I'm including two of my CNs in the principal carbon chain and excluding one because it cannot be included at all. My principal carbon chain is of 5 carbons now, so the name will be pentane, and two nitrile groups are there, so it will be dinitrile, and the third nitrile group is out of the chain, which is acting as a branch now, hence the name will be in prefix and it will be 3-cyano. This is a new way of naming and the preferred one, and this is the old way of naming. So if the question is asked and both the options are given, you will mark both of them if it is a multiple answer correct. If only one option you have to mark, then you will be marking the new way of naming of the compound. Okay, so multiple nitriles if will be there, you can exclude them from the chain, and you can mark it as carbonitrile rather than writing nitrile by counting the carbons of nitrile group in the principal carbon chain. So this is about the naming of nitrile, or you can say cyanide groups. Let's talk about the isocyanide group now. So representation of isocyanide group is N triple bond C, where N is connected to the principal carbon chain, and you have one dative bond between carbon and nitrogen, which can be represented by a plus on nitrogen and minus on carbon. Right? So this is the structure of your isocyanide group. What is the suffix we use for isocyanide? Isocyanide. What is the prefix we use for isocyanide? Isocyano. Okay, so only two simple terms. There is no special case, hence it is easier to remember and faster to do. So let's see the generic formula. Generic formula is RNC. Alkyl isocyanide is what we call it. Alkyl will represent the carbon chain of, that is R. That means we will count the number of carbons, and these will be actually, so basically when we are saying principal carbon chain, what we are considering is nothing else but NC, or to be very honest, it is just C. Okay, and the R group is actually acting as a branch. That's the reason why we're writing the name as alkyl. Alkyl represents the R part, and isocyanide represents the NC part. So this is your main principal carbon chain, and R is going to be a branch. So if I have N triple bond C, there is only one carbon, hence alkyl group is going to be methyl, and then comes your isocyanide. So the carbon of this is not counted. Basically, this is your actual chain, and the other R group is just a branch on the isocyanide group. Again, here we have three-member carbon chain over here with NC. NC will be represented by isocyanide, and this three-membered ring will be called as propyl. Come to the next one. I have two groups over here. Now look at this example very carefully. I have taken the three-membered carbon chain. At one end, it is connected to N triple bond C, and the another end it is connected to C triple bond N. So don't get confused over here. Here the linkage is between carbon, and here the linkage is between carbon and nitrogen. Now, when I was talking about the functional groups in the beginning, at that time I told you that CN and NC both have the same priority when you talk in the terms of priority list. But when you have to compare the priority between cyanide or isocyanide group, your CN has more priority than NC. Remember this always. Okay, so here obviously this is more prioritized group, or this is the higher priority group. My numbering will start from here 1 2 3 4, and this will be acting as prefix. So on the fourth carbon I have an isocyano group, and total number of carbons 1 2 3 4, so butane nitrile. Okay, this is an important point when you have to compare between CN and NC. CN has higher priority than NC. Now look at this compound. When we have cyclic structures also, in that case also the name doesn't change. There is no special case which comes into the picture. The name is very simple. If it is suffix, then you will be using isocyanide. If it is prefix, you will be using isocyano. So here cyclohexane, isocyanide, simple. Now we have discussed about the naming of cyanides and isocyanides. You have to do all these questions on your own. Questions are really simple, just simple application of whatever we have learned till now. So try out these questions, and then we will discuss this in the class, doubts class mostly. Or if you have any doubt in these questions, or you're getting stuck anywhere, you can simply send me a message, or you can just raise a question in the doubts group and we will help you out. Here I just want to bring something in your notice. Look at the question number 5, though I'm not here to tell you the answer for this, but just one small discussion. So I have three groups over here. One is bromine, one is cyanide, and one is OH, right? Now if I have to compare which is the highest priority group among all the three, cyanide is better group than OH and Br. Okay, so this will definitely get the position 1. Right, we have already discussed this before, that higher priority groups we try to give them the lowest possible position. Now I have two ways. Either I go this way and I get position 1 for here, 2 for this, and 1 2 3 4 5 and 6, like this. So my Br gets 6th position and my OH gets a 2nd position. And the other way is that I number it in such a way that my CN gets 1st position, Br gets 2nd position, and OH gets 6th position. Which one would I prefer? Now here you have to understand one thing. Here Br and OH, both the groups now have to be treated as prefix, basically lower priority groups. So there is, you can say, their all importance is gone now. Now both are at the same level. So we can't say that OH is better in the priority list and Br is later in the priority list. Now once you have chosen the highest priority group or senior group, these two groups have no value at all. Okay, now they are at the same level because all of these are going to be written in the prefix. So here what will get the preference? The alphabetical order will get the preference. So bromo comes first in the alphabetical order, hence I'll try to give it the lower number, and hydroxyl comes later in the you can say alphabetical order, and hence that will get the later number. So the numbering will be 1 for CN and 2 for bromo, and then whatever respective position OH will get, it will get. Okay, so here you don't have to look out for the you can say positioning of prefixes on the basis of their priority in the priority list. Instead you have to go by the alphabetical order. This you have to keep in mind while naming the compounds. Let's talk about the next functional group. The next functional group what we have is amide. What is amide? Let's see. Amide is C double bond O NH2. This is the group, and this we also call it as your carboxylic acid derivatives. Carboxylic acid derivatives. If you remember, we have discussed why these are called as carboxylic acid derivatives, because all of these compounds, the ones which have C double bond O and then some group over here, All these groups can be prepared using carboxylic acid, and you just have to replace OH of carboxylic acid with some other group, and this is the generic form for it. And all these compounds are also termed as carboxylic acid derivatives because these have some structure similar to carboxylic acids. Okay, so functional group is CO and H2. There are if it is acting as a higher priority group, then the suffix name is amide or carboxamide depending upon the type of chain. So carboxamide is a special name. In the generic cases, we will be using amide as a term. And if I have to use it as a prefix or lower priority group, then carbomoyl is the name for amides. Okay, so let's start with the generic formula. Generic formula is RCONH2. When we are writing the name for it, the name is going to be the combination of alkane plus amide. But as we have already understood this before, that E will not come if the two vowels are together. So the name will become alkanamide. This alkane will actually include the carbon of R plus C of amide. So when I have this example, the first and the smallest amide group what we have is HCONH2. That means only one single carbon. The name will be methanamide. If I have to write the common name for it, formamide is the name for the, or you can say formamide is the common name for this compound. Okay, because form is the term which we use for such kind of structure. So this structure is called as form. Wherever this structure you will see, you will see that the common name will have the term form in it. We will be talking about this in detail. Next is CH3, CONH2, again two carbons, so ethanamide will be the name. If I have to talk about the common name will be acetamide. Now again, let me tell you, wherever you will see this group CH3, C double bond O, not only in this compound, but any compound, if you have this form anywhere or this part anywhere, then in the common terms or in the common names you use the term acet. Okay, we will be discussing about the examples of the usage of form and acet in multiple different functional groups, but these are the specific common names. Wherever you will see form written, that means it has HCO group present. If you will see acet written anywhere, that means CH3CO group is there. And now what is the rest written will decide basically what other group is present along with this carbon. So if it is amide written, that means NH2 is there. Correct. And if there is something else written, then that will be the thing. So we will be discussing about form and acet in detail in next few slides. Okay. Let's see a few more examples. So next example is CH3, CH2, CH, CH2, CH3, CO, NH2. Now, here I can see that CONH2 is actually present on the third carbon, but let me tell you, this is also a chain initiating group, so you will never say this is present on the third carbon, but if it is the only group or the higher priority group in the chain, then the chain will initiate from here. That means this group will get the first position, irrespective of the chain length. So my actual chain will be, this is my principal carbon chain. So this is carbon 1, 2, 3, and 4. It will become butanamide. And on the second position, we have ethyl present. So 2-ethyl butanamide. Next compound, we have HCONH3. Now here you have to understand one thing very carefully. We have spoken about amines, and at that time I told you amines can be of three types: primary, secondary, and tertiary, depending upon how many R groups or how many carbon chains are connected to nitrogen. Exactly same way, in case of amides, I have C double bond O NH2. If this is the structure, that means this CONH2 is connected to R from one end only, that is carbon, and this kind of amide is called as primary amide. Okay, if I have RC double bond ONH and then I attach one more R group on this nitrogen by replacing it with by replacing hydrogen with another R. Now this R group or this carbon chain can be of the same length, can be of the different length. So if I remove one hydrogen and when I attach one carbon chain over here, then it is called as secondary amide. And if I replace one more hydrogen with R group, basically no hydrogens anymore, I'm just putting R and R dash to represent that there are three different carbon chains, then this amide will be called as tertiary amide. So here also there is a degree, primary, secondary and tertiary, depending upon how the nitrogen is behaving. If nitrogen is not connected to any alkane chain, then it is primary amide. If it is connected to one carbon chain, then it is secondary. If it is connected to two carbon chains, then it is tertiary. So here if you look at this molecule carefully or this compound carefully, I have Hco and H. Look at the nitrogen when you want to figure out the degree. NHCH3. This is definitely not the primary amide. This is secondary because primary amide will have NH2. This is NH with one R group over here. So how will we name such compound? First of all, let's see how many, see, this CH3 or whatever the group present here with the nitrogen is always going to act as a branch. No matter this is lengthier than your original carbon chain or not. So this is my main compound and this R group is going to be a branch. Okay, so now how many carbons I have in the main chain? Just one. So the compound will be methanamide, and I have a branch that is R present on nitrogen, and we will call it as methyl. How to represent that this branch is present on N but not on the actual carbon chain? By representing its point of attachment. So N-methyl methanamide represents that you have a methyl group which is present on the nitrogen of amide, and your actual amide is methanamide. That means your actual carbon chain has only one, or actual amide chain has only one carbon. The another methyl group is just a branch which is present on nitrogen. Look at another example carefully. Now again I can see my nitrogen is not NH2, it is NH with CH3, so this is my branch. What is my principal carbon chain? This whole thing is my principal carbon chain. How many carbons do I have? Two carbons, one here, one here. So ethanamide will be the name, and methyl group is present on the nitrogen, and that is why it will be called as N-methyl ethanamide. We have some common names also for them, and common name for the first one is N-methyl. So N-methyl still remains the same, there is no difference. And as I mentioned earlier also, that H CO group is called as form in the common name. So we have named it formamide. Similarly, I had told you CH3, C double bond O group is called as acet. So that's the reason why we have called it as acetamide instead of calling ethanamide. Okay, so this is form is the term for meth in case of common names, and acet is the word for ethan in the common names. But not only ethane, but specifically this group. So it should be CH3, C double bond O, or HC double bond O, and then only we will have the term form and acet being used in the common names. Okay, now look at the next compound. I have HCO and CH3CH3. Now here we don't have even single hydrogen with nitrogen, so here amide is a tertiary amide. Two branches are there here. Both of these will be acting as a branch. This will be my main chain. Main chain has only one carbon, hence the name will be methanamide. And two branches as methyl, so it will be dimethyl. Both the methyl groups are present on nitrogen, so it will become N, N dimethyl. Okay, now if I have to write the common name for it, name will be dimethyl, same as this, formamide, just to represent that there is a HCO group present over here. This is an important compound or important solvent, you can say. We will be using it in the later lectures. Okay, so this is an important solvent which you will find in the whole organic being used multiple times, and in short it is also written as DMF. Basically DMF is nothing else but dimethyl formamide. Look at the next compound. I have CH3CO and CH3CHC. Again, these two are branches, so dimethyl N, N. I have missed writing it. And the whole principal carbon chain has two carbons, so it will be ethanamide. If I have to write the common name for it, it will be dimethyl acetamide. I hope you would have understood why it is acetamide, because it has CH3CO group present here. And we also write it as, in short, DMA. Now look at the next few compounds. So next compound we have is NH2CO, CH2, CH2, CO, NH2. That means amide group is repeating twice, right? So here the name will be, how many carbons are there in total? So it is 1, 2, 3 and 4. Total 4 carbons, so butane. And because there are two amide groups, so we will be writing diamide. We will not be skipping E here because we are not encountering A but D. So we will not write butane diamide, we will write butane diamide. Next compound, what we have is CH3NHCO. So basically you have a branch on nitrogen over here, and then CONH group. Then again CH2CH2 CONH group and branch. So here secondary amide. Again, secondary amide. Look at the question very carefully. When you are planning to write a name, you can't just get panicked just by looking at the length or complexity of the chain. Just try to understand it very carefully. So this is my secondary amides on both the ends, and it is very similar question as the ninth one. The only difference is you have just two branches on nitrogen. That's all. So how will you be mentioning these branches? First of all, let's write the same name, butane diamide, because it is butane diamide. Now we have to take care of these two branches. So branches is one methyl here and one methyl at the other end. So we will just write it as dimethyl. Now how to represent that these two methyl groups are not on one nitrogen but two different nitrogens? What we will do is this, let's mark it as N. One nitrogen will be mentioned as N and another nitrogen will be mentioned as N dash. N dash is nothing else but to represent that these two methyl groups are present on two different nitrogens. It's not a difference between nitrogen. This is one kind of nitrogen, this is another kind of nitrogen. So that's not the thing. It's just like talking about two different nitrogens in the carbon chain, or two different amides nitrogen are carrying methyl group individually. Okay, so N comma N dash represents that one CH3 is present on one nitrogen and another CH3 is present on another nitrogen. Come to the next example. Next example, there is one amide group here, one amide group here, and then CH double bond CH. Simple question. Total number of carbons 1, 2, 3, 4. There is a double bond in between, so instead of butane, it will be butene and diamide. That's all. Next compound, very quickly see, we have CONH2 group, CH2CH2, and then COOH, so carboxylic acid group. Now here what we have to do, we have to figure out which one has the higher priority. We know that carboxylic acid has the higher priority, so we'll start numbering from here. 1, 2, 3. Mind it, mind it, mind it. Very important point I'm going to tell you. Only aldehydes and ketones are the groups which, even if they are low priority groups, then also their carbon is counted in principal carbon, or let me just write it the total thing, or parent chain. Basically what I'm trying to tell you is that when you talk about aldehyde or ketone, we can still include ketone. We have no choice, it is in middle of the chain, and aldehyde is a terminal group or the initiating group. But even if both of the groups, aldehyde and ketone, are acting as the low priority group, still their carbon can be included in the parent chain counting. But that's not the case in all other groups. Any other group which has carbon in it, but it is acting as a low priority group, its carbon will not be counted, in the principal carbon chain while naming. Only when they are not acting as a senior group but a lower priority group. So here we already understand that COH is the higher priority group or senior group, and CONH3 is a low priority group. Till now, when we had only CONH2, we were counting the carbon of CONH2 in the principal carbon chain. But now here CONH2 is a lower priority group, or you can say is a prefix, and hence we will not count its carbon while marking the principal carbon chain. It's not only about amide, but any group will behave like this except aldehydes and ketones. Okay, so that means my principal carbon chain ends here, right? So my principal carbon chain has how many carbons? 3. So it will be propanoic acid, and this will have a prefix, that is carbomoyl. So that is 3 carbomoyl. This carbomoyl represents that CONH2 whole group. We are not counting, again and again I'm repeating, we are not counting the carbon of CONH2 when it is a low priority group. And this is not only in this case, but in all other functional groups except aldehydes and ketones. I think, discussed one example earlier also when we were talking about aldehydes. We will be talking about further more examples going forward, or further other groups when we'll be dealing with. You will see such examples, and I'll show you that no other group's carbon is counted in the principal carbon chain when it is lower priority. Now look at the next example. I have an amide over here, and then I have a ketone over here. If you see, this is a ketone, and I have an amine over here. Three functional groups I have. One is ketone, one is amide, and one is amine or amine, whatever you want to call it. So we have to figure out which one is the higher priority group. So we know that the amide group is a higher priority group. So this will be my principal carbon chain. As I mentioned, ketones carbon is included in the principal carbon chain. So it will be 1, 2, 3, 4, and 5. 5 carbons in the principal carbon chain. So it will be pentane amide. I think I have written amine over here. By mistake, it is amide. Pentane amide. Okay. Now I have a ketone present on which carbon? So this is my first carbon, this is second, this is third, this is fourth, and this is fifth. So ketone is present on the fourth carbon, whereas my amine group is present on the fifth carbon. Prefix for amine is amino, and for ketone it's oxo. So we will write 5-amino 4-oxo pentane amide. I hope it is clear to you. Understand this, see this again. If you have not understood, try to solve it on your own. And because you will be encountering such kind of questions, you have to solve such kind of questions where there are multiple functional groups present. Now let's talk about next few examples where we will be using the special name of amide. So special name for amide is alkane carboxamide. This is applicable in again two conditions. One, if the chain is cyclic. Another, if amide group is repeating multiple times. Amide is repeating. Okay. Generally, we prefer, you will see mostly it is being used when the compounds are cyclic. So let's see the first example. I have a cyclohexane with CO and H2, so I can simply write cyclohexane carboxamide. Again, when I'm marking this chain, I'm not counting the carbon of amide group because it is outside the cyclic chain. Okay, so we will not be counting the carbon in case of special case. Wherever we are applying the special case, we will not be counting the carbon of amide here for the principal carbon chain. So this is my principal carbon chain, and this group will be called as carboxamide. So carb is already there. That means carbon of amide has been already taken care of. Another example, I have two amide groups and then cyclopentane. So it will be cyclopentane 1, 3. This is first, second, third, and first, second, and third. So 1, 3 dicarboxamide. Okay, so you can write it as cyclopentane 1, 3 dicarboxamide. Simple. I think I had written something over here. I have rubbed it because it was written by mistake. That is not the answer, or that is no name for this compound. Okay, so I've just deleted it. You can delete if just in case you have copied without even me explaining the name of the compound. Okay, now again I'm giving you some homework over here for this amide groups. So you have to do these questions. First, second, and third I have mentioned, and there might be some few more questions. Let's see. Yeah, so there are a few more questions. Try out these questions on your own, and again we will discuss the answers, or I'll give you the answers in the doubts group, or you can say doubt session. So note down these questions and solve them on your own. Now the last compound for the day is naming of acid halides. Okay, so naming of acid halide. What is acid halide group? COX, where carbon is connected to the principal carbon chain, is the last group what we are going to deal with today. In this group we have X, where X represents chlorine, bromine, iodine, and fluorine. Anything we can have over here out of these four. The generic name for this compound is acid halide. Depending upon what halogen you have used, the name will be actually given. So what is the suffix for it? OL halide. Okay, halide will change depending upon what halogen you have. If it is bromo, then bromide. If it is chloro, then chloride. If it is iodo, then iodide. And if it is fluoro, then fluoride. Okay, so this is one name, and there is a special name for it, that is carbonyl halide, and we will be using it only in these special cases. If it is acting as a prefix, then the name is halocarbonyl. Again, this halo will depend upon what halogen is present. Let's quickly see the application of this. The generic formula of the compound is RCOCl. When we are writing the name of this compound, we will be counting the carbons of R and this C both. The name of the compound is alkanoyl halide. So alk will represent the number of carbons. I think I have done a spelling mistake over here. Let me correct it. So it's not alkanoyl, it is alkanoyl halide. My bad. So it will be alkane will represent the total number of carbons and the bonding type in the chain, and then oil halide will be the suffix. Okay, so look at the first compound. We have CH3COCl. This is the smallest, you can say, acid halide we have, and you have two carbons in the carbon chain, so it will be ethanol chloride, and this is the most widely used acid halide also. Okay, this compound is also called as acetyl chloride. Why it is called as acetyl chloride, I have told you. COCH3, this group is acid group, so the compound name is acetyl chloride. Okay, this is most widely used acid chloride. You will see its usage every now and then in the organic chemistry. Next is CH3CH2COBr. The main chain consists of 3 carbons, so propanol, and this is bromide. Here, look at the next compound. I have 2 acid halide group or acid chloride groups with 2 CH3. So total number of carbons are 4. So butane diol chloride. Next compound, I have 1 acid chloride group, then CH2CH2COOH. COOH is the higher priority group, hence the numbering will start from here: 1, 2, 3, and 4. Not 4, my bad. I'm sorry. Not 4. 1, 2, 3. Why not 4? Why not 4? Just now I have explained you in the previous slide that we do not include the carbon of the lower priority group in counting of the principal carbon chain if it is anything apart from aldehyde or ketone. So COCl's carbon will not be counted. So your main chain will end up here only, and this will be propanoic acid. And what is the name of such a group in the prefix? It is halocarbonyl. That means it will be chlorocarbonyl. So the name is chlorocarbonyl, and the position is third, so it will be 3-chlorocarbonyl. Okay, look at the next compound. I have COCl, I have a ketone over here, and I have a Cl over here. So 3 functional groups we have. One is chloro, one is ketone, and another is acid halide. The total number of carbons in the carbon chain are 1, 2, 3, 4, and 5. Out of these 3, which one is the highest priority group? This is the higher priority group. Mind it, COCl is also a chain terminating and chain initiating group. So when this is higher priority or this is the only group in the chain, your numbering will always start from here. Okay, so this is your chain: 1, 2, 3, 4, and 5. So I have chloro on the 5th position. I have oxo due to ketone on the 3rd position, and then the name of the chain will be pentanoyl chloride. So 5-chloro, 3-oxo, pentanoyl chloride. Let's quickly discuss the special names also. Now here I'm having an understanding that you guys would have been much more comfortable by the names, and that's why my speed is a little faster. I'm not explaining each and everything because I'm hoping that by now you would have got what is the way of naming. If you still struggle at some point of time or in some questions, you please let me know in the doubts class. Let's talk about the special name. Special name is alkane carbonyl halide. Again, the condition for these names to use is either the chain should be cyclic or the group should be repeated multiple times. Group is repeated multiple times. This is the usage condition, which is common in all the cases wherever we are using these special names. Okay, the first compound we have cyclohexane. COCl's carbon will not be included in the main chain because the name already contains the carbon. So we have carbonyl halide. It actually counts the carbon. It is basically showing up that the carbon is there in the group, and we are not separately counting it in the principal carbon chain. So name is going to be cyclohexane carbonyl chloride. Next, if I have 2 COCl's, it will be cyclopentane 1,3 dicarbonyl chloride. Simple naming. In this compound, again, it's exactly similar case as what we have seen in multiple other special name cases. If there are 2 ways of naming this compound, either you take this as a principal carbon chain and exclude COCl from your main chain and do not count its carbon. In that case, the main chain will be propane, and the COCl will be called as tricarbonyl chloride. 1, 2, 3, mentioning the position. Or the other way is you take this as a main chain in which 5 carbons will be included, and the sixth COCl, or you can say sixth carbon, which is because of the COCl or the COCl group itself, is excluded from the main chain and will be acting as a branch. So the name of this COCl will be prefix. Whereas this whole thing will be counted as 5 carbons, it will be pentane diol chloride, and the name of this COCl will be 3-chlorocarbonyl. This is the old way of naming, this is the new way of naming. We will prefer new way of naming when we have to write it. When it is given in the question, depending upon it is a single answer correct or multiple answer correct, we will choose our choices. In multiple answer correct, we will mark both the answers right. If it is a single answer correct, we will be marking only new one as the right answer. So here we are done with acid halides. Also, in next class we'll talking about last few functional groups which are left. We'll do some practice and mostly we'll be done with the naming of the functional groups.